Hello, can you hear me?
Yes, sir.
Okay, we'll continue with waves and sound. Here, a source of sound has a frequency of 240 hertz. When the observer O and source move towards each other at a speed v with respect to ground, measured frequency by observer O is 288 hertz. The figure is shown. This is like this. This is like this. This is case one. And case two is this case where the source is moving this way, an observer is also moving this way, and the frequency is n hertz here. You have to find out n.
Okay. Sir, 200. Sir, you're muted. Sir, uh, I'm not able to hear you if you are speaking.
Hello, sorry, I got a call. So what did you get?
Sir, 200.
200. Okay, that is correct. So this is simple Doppler's effect. You just have to apply the formulas, right?
Yes, sir.
So this is JEE Advanced 2024. This is the kind of easy question that you have to get for sure.
Hmm.
Uh, okay, let's look at the next one. One second. Okay, a string of length 1 meter and mass 2 into 10 power minus 5 kg is under tension capital T when the string vibrates two successive harmonics are found to occur at frequencies 750 hertz and 1000 hertz. The value of T is how much in newtons?
Sir, 50.
Hmm.
No, 1 second.
Hmm.
Five, five.
Hmm. So basically, you have to realize that because it is two successive harmonics, it cannot be a string fixed at one end only, right?
Yes, sir.
So it has to be string fixed at both ends, and then you will just put the equations n plus 1 by 2l
Yes.
root over t over mu minus n by 2l root over t over mu will be 250.
Yes.
And after that, it is obvious 1 by 2l root over t over mu will come and you'll get the answer.
Yes.
So main thing is to realize whether it is string fixed at both ends or not,
Hmm.
right?
Right.
Okay. S1 and S2 are two identical sound sources of frequency 656 Hertz. S1 is located at O and S2 moves anti-clockwise with 4 root 2 meter per second on a circular path around O. So the figure is shown. This is S1, this is O, and there is a circular path. This is position Q, this is position R, this is position P, and S2 is moving here. So with a velocity of 4 root 2 meter per second, there are 3 points PQR on this path such that P and R are diametrically opposite, while Q is equidistant from them. A sound detector is placed at P. S1 can move along the direction OP, along direction OP, and speed of sound in air is given as 324. Now, when only S2 is emitting sound and it is at Q, frequency measured by the detector. So only S2 is emitting sound and it was at Q. At that moment, what is the frequency measured by the detector? And the detector is placed at point P, right?
Yes.
This is the detector. Okay, it's just we don't have to worry about S1 at all here, I think,
Hmm.
because only S2 is emitting sound.
Yes, sir.
So it's actually a simple Doppler effect. This is going at 4 root 2. You have to measure the speed and all along the appropriate line, right?
Yes, sir.
So just find it out.
Uh, Sir,
Hmm.
do I have to approximate or?
It's coming as a nice answer if you're doing it correctly.
Sir, that's not an integer. 8.2.
It is an integer. You have made some mistake. See, this
Yes.
point, this source is moving away, right?
Yes, sir.
4 root 2, but you have to do it along this line, right?
Yes, sir.
What is the component of the velocity along this?
4 meters per second.
So 4, right?
Yes, sir.
So 4 away, and you just have to do frequency detected is it is source moving away and observer is here.
Right.
So it is 324 by 324 plus 4, right?
Yes, sir.
Into F naught, which is 656.
Hmm.
This is 328. This cancels with a 2. You have
Right.
to find observed frequency, no? 648 is coming.
Yes, sir. One second.
What were you doing?
Sir, I made some mistake in calculating. Oh, I didn't notice. I wrote it wrong.
Right, so it is simple Doppler's effect where source is moving away and detector is observing stationary.
Yes, sir.
The velocity along the line is 4, so you just have to do this.
Yes, sir.
So the question is so long, but it's actually so super easy.
Hmm.
Okay. Uh, Now, same question. The second part is consider both sources are emitting sound. S2 is at R and S1 approaches detector with a speed of 4 meter per second. The beat frequency measured by detector is equal to what? Obviously, both the sources are identical sources. If you draw the figure again, S1 is here. This was the circle. S2 is at R, right?
Right.
And point P is here. And this is coming here at 4 meter per second. S2 is already always going at 4 root 2 and all, right?
Hmm.
Speed of sound in air is 324 they have given. And the frequency of each of them is 656 hertz.
Yes, sir.
You have to find the beat frequency. What happens due to S2? What is the frequency due to S2 that P will hear?
Sir, I'm a bit confused about that.
Why?
Uh,
See, S2 is moving, but is it moving away from the source right now?
no.
Whenever you do Doppler's effect, it has to be along the line of the detector and stuff, right?
Right, right.
So actually, this velocity doesn't count. The
Yes,
velocity along this line is zero.
yes,
So right now, there is no Doppler effect due to S2. Frequency
yes.
due to S2 that P hears is simply 656. The Doppler effect will be due to S1,
Hmm.
which is approaching at 4. So we can calculate by formula to find out what is the frequency due to S1,
Yes,
right?
one. Yes, sir.
It is approaching, so it will be higher than usual. So 324 by 324 minus 4 into 656, right?
Hmm.
So the frequency here will come out to be 324 by 320 into 656.
Yes,
Now, this frequency is slightly different from this frequency, and that is what causes the beat frequency, right?
yes,
Beats happen when there is slight difference in frequencies.
yes,
So you can take the difference between the frequencies, 656, 324 by 320 minus 1. So which is basically 4 by 320. So 1 by 80 into 656, right? This will
right.
be 8.2. So answer is beat frequency is 8.2 hertz. And again, this is a simple question on Doppler's effect. Previous question, when the particle was here and going like this, again we calculated velocity along this line.
Yes, sir.
Here also along this line we have to see, and this is like this, so 0,
Hmm.
right?
Right.
So you need to revise this Doppler effect stuff. Some very easy questions are coming. Both these questions are 2023 paper 2.
Yes.
If you know your stuff, you will get full marks if a question like this comes.
Right.
Okay. Do that revision in the next 1 or 2 days. Make sure that you have revised sound and waves fully.
Okay, sir.
Uh, okay, 1 second. Okay. A source approaching with speed u towards the open end of a stationary pipe of length L is emitting sound of frequency F naught. The farther end of the pipe is closed. Speed of sound in air is V, and F naught is the fundamental frequency of the pipe. For which combination of U and Fs, so is emitting sound F naught. So this source was emitting sound of frequency Fs. This is Fs, this is F naught is fundamental frequency of the pipe. For which combination of U and Fs will the sound reaching the pipe lead to resonance? Lead to resonance. Options are U is 0, 0.8 V and Fs is equal to F naught. B, U is 0.8 V and Fs is equal to 2 F naught. C, U is 0.8 V and Fs is equal to 0.5 F naught. And D, U is 0.5 V and Fs is equal to 1.5 F naught. First of all, it's a closed organ pipe, right? One end is closed, one end is open, right?
Yes, sir.
So there in that closed organ pipe, you should know from theory that only odd harmonics will be possible, right?
Yes, sir.
So what the closed organ pipe will have is F naught 3, F naught 5, F naught, and so on, right?
Hmm.
Correct, no?
Yes, sir.
Great. Now there is some Doppler effect stuff happening. So Fs was the emitted frequency, U is the speed at which it is approaching, right? So
Right.
what is the frequency that appears to the pipe, right?
Hmm.
Fs dash, what it will appear is Fs times V minus 0 by V minus U,
Right.
because the detector is not moving, the source is moving, right?
Yes, sir.
Do you understand what I'm saying right now?
Yes.
So the frequency that appears there is Fs into V by V minus U, right?
Yes, sir.
For resonance, what has to happen? This frequency should match these, right?
Yes, sir.
So now this is like an odd multiple of F naught. So 2n minus 1 into F naught, you can call it, right?
Hmm.
N should be an integer and this should match this, right?
Yes, sir.
Now you just have to check the options when it matches.
Sir, first and last option.
Hmm. A and D is the correct answer. You can just put U is equal to 0.8 and eliminate which ones are right from here, right?
Yes, sir.
So again, the point is, even if the question looks weird, it is not very difficult. You have to realize if the pipe is closed at one end, open at another end, what harmonic set happens, right?
Right.
That's standard theory that it will be odd harmonics,
Yes, sir.
right? And after that, you have to do Doppler effect formula and say that resonance will happen when two waves have constructive interference, right?
Yes, sir.
Frequencies must match for that to happen.
Right.
So that's it. This was 2021. Then, okay. So a stationary tuning fork is in resonance with an air column in a pipe if the tuning fork is moved at 2 meter per second in front of the open end and parallel to it, the length of the pipe should be changed for the resonance to occur with the moving tuning fork. Speed of sound in air is 320. Find the smallest percentage change required in the length of the pipe. Basically, for resonance to occur with the moving tuning fork. What is the basic frequency of a air column in a pipe like this? Open end air column.
Basic.
Fundamental frequency of the air column.
Um,
See, we are saying no tuning fork was in resonance with the air column, right?
right.
So tuning fork has to have same frequency of vibration as the air column's vibrations, right?
Right. Yes.
So what is the fundamental for that air column, which is open and both end?
Um,
Actually, the air column is has an open end and a closed end, right? Because they have said open end.
right.
If it was open at both ends, they would not have said open end, right?
Yes, sir.
So it will be V by 4L and 3V by 4L and all again, right?
Right. Yes, sir.
See, the odd harmonics one, right?
Yes, sir.
The basic one, the smallest frequency is V by 4L, right?
Hmm.
Because it is open at one end, closed at the other end. If it was a open at both ends type of pipe, then we would have had V by 2L, 2V by 2L, 3V by 2L and all.
Yes, sir.
Again, this is theory stuff. Okay. If you don't know this, you need to revise theory.
Hmm.
So right now we know that stationary tuning fork should have frequency of V by 4L.
Hmm.
Then we will do Doppler effect on it on at 2 meter per second, right?
Yes, sir.
It is being moved around. So we'll
Uh,
say 320 by 320 minus 2 should be the V by 4L dash, right?
Yes.
For the new resonance, the length has to be changed, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
Okay, so we are getting basically 320 by 318 is equal to V by 4L dash here,
Right.
correct?
Right.
And earlier we had something, right? So V by 4L was equal to the F. This is multiplied by F, by the way. I forgot to put that, right?
Hmm.
F was this, so we can get a ratio of L dash by L now, right?
Yes, sir. Right.
V by 4L times 320 by 318 is equal to V by 4L dash. So you are getting L dash by L is equal to 318 by 320.
Hmm. Right.
Is it clear what is happening?
Yes, sir.
So 1 minus L dash by L will be 2 by 320, which is L minus L dash by L, which is 2 by 320. So this will multiply this by 100 will give you percentage change.
Yes, sir.
So 100 by 160%. So it will be 100 by 160 only, no? 200, 200.
Yes, sir.
Right. So it will be 5 by 8, right?
Hmm.
So we are getting 0.37, point 0.6 something,
0.625.
0.625% like that.
Hmm.
Notice that we could have started with a 3V by 4L and all, right?
Hmm. But smallest percentage.
But the smallest percentage was being asked. If you started with 3V by 4L, then you would have gotten a higher value of percentage, right?
Yes, sir.
Correct, no?
Hmm.
So again, this air column resonance with a fork and similar concepts are being asked multiple times. Okay.
Okay, sir.
This is 2020. 10 2019 also there is a question. One second. There is a match the following in 2019, but I think you can do it. I don't think we need to discuss this one. Next one is okay. Let's do one more Doppler effect question. This is 2019 S2 S1. So this is a train S1 moving with this velocity. This is another train which is stationary, and observer O is moving at 36 towards S2. Both the trains are blowing whistles of frequency S1, S2. Frequency is 120 hertz. And when O is 600-meter away from S2, the distance here is 800-meter. You have to find number of beats heard by O. Straightforward question if you understand Doppler's effect and basics, right?
Yes.
Try to do it.
Sir, what speed did they give for sound?
108 kilometer per, oh, speed of sound, 330.
Um,
You will
sir,
not get an integer answer.
yes, sir.
What is it
Uh,
coming?
8.13
Hmm.
around that.
Hmm. This is the beat frequency. Again, you have to be careful about the line in which the velocities are.
Yes, sir.
This is stationary, so there is no issue with this, right?
Hmm.
This is moving like this, but you need to measure velocity along this line.
Yes, sir.
That's why the distances were given to find the angles.
Yes, sir.
And after that, you have to do the difference of frequencies. It's straightforward only, right?
Hmm.
This was 2019. So, okay. Okay, this type of questions we have seen most of the types. We will look at the other uh, parts. Like there are some other parts of the sound and waves chapter, wave equation based questions. So that we'll probably do in the next class. Okay.
Okay, sir.
But maybe next class we'll do complex numbers. We had started that, but we have not done much there.
Right.
Maths you are revising, right?
Yes, sir.
Work on coordinate for sure.
Yes.
And all the easy parts of calculus, you need to make sure that you are good in that.
Hmm.
We'll work on complex numbers in the next class.
Okay, sir.
Okay. Fine. That's all for now then.
Thank you.
Bye.